Hi, it's Bruce Rouse here from the Sustainability Education Academy, and having a chat with Ewen Anderson here from the company PX3, or the organisation PX3, which is a UK-based organisation working in IT and reducing carbon emissions in IT, and doing some very interesting work, I think. So just want to have a bit of a chat with you. And Ewan, thanks for coming on and being willing to chat. It's very nice to be able to meet you virtually. And I guess the UK summer is about as warm as the Australian winter right now in Melbourne. It's I
Yeah,
think I'm probably
probably.
about 12 degrees here. What's it like over there?
Similar, yeah. I mean, we're getting up to about 19 degrees at
Oh,
peak when the sun's shining. But
oh.
when you're not in the sunshine, believe me, you can definitely still tell you're in the UK. So
Yeah, I met someone at my school recently who just migrated from the UK, my kid's school, sorry, and I was complaining about the Melbourne weather, and he was saying, "Oh, it's actually very good here." So, um, yeah.
yeah,
Um, so,
but we have
so you
seasons,
and
proper
yeah,
seasons.
yeah, you're doing some really interesting work with computers, and can you tell me a bit about, give me a bit of an overview of what you're doing?
Sure. I mean, we set the company up, myself and my co-founder, Justin Sutton Parker, about 5.5 years ago. And really, what we wanted to do was address a gap that we saw in the market, which was for independent analysis of the carbon footprint of information and communication technology. So there was information available from vendors about what they said their carbon footprint was, but even that was quite limited. So what we really wanted to do was establish a way of giving organizations proper scientific information about carbon footprint to help them plan their strategies and make their procurement decisions with sustainability as one of the key factors that they would build in. So it's never going to be the only factor, because cost, user experience, functionality, they all come into play. But we think that having that independent view on sustainability is something that's really important for organizations to have. So we're based out of one of the leading UK universities, University of Warwick, and that's where my co-founder did his PhD in computing and sustainable IT. And I think he's now got 7 already published papers on the topic, but heading for 9 published scientific papers in the academic press, reviewing this topic. And I think that, the main issue that we look to address is really, what is the carbon footprint of devices in their real world use? So not what does it consume when it's not being used, which is typically what's measured, but what's the genuine power consumption and therefore emissions from a device in its typical daily use for productivity tasks, and then what's its total carbon footprint. So from manufacturing and resources through to disposal. So to give organizations that view on that, but also to give them the ability to run what-if analysis. So to say, well, what if we kept the devices for another year? What if we changed the operating system? What if we moved some of those workloads from the data center to the hypercloud or a hypercloud provider? What would be the impact on our overall footprint, but also the overall carbon footprint for the planet?
It's really fascinating. I've been working in energy efficiency for over 20 years now, and certainly computers have come down a lot in their power usage and IT devices more broadly. Like I remember 20 years ago, computers would be drawing upwards of 100 watts of power. And now I think my laptop that I've got here, I actually haven't measured it. I should measure it. I'm a big fan of measuring stuff. I don't know what it's using. It's probably pulling about
I haven't I done that? Yeah.
25 watts. I remember once seeing a photocopier which in standby mode was pulling over 100 watts. It was ridiculously high. But of course, I'm fascinated to hear you talk about the real world use, because of course we have, I think it's the EPA has, no, Energy Star in the US has the computer ratings. And in the past, I've referred energy users to those ratings, to help inform their purchasing decisions around around OT equipment. But of course, that just captures the operational usage and would be under some sort of theoretical test cycle, I presume.
I mean, you've hit the problem exactly there. In the Energy Star ratings measure under specific test conditions the power draw during off, sleep, long idle, and short idle. What they don't do is measure what the device draws when actually being used, because that's a much more complicated thing to do. So they will extrapolate from their data what they believe a typical energy consumption would be. What we do is we genuinely measure that under the same laboratory conditions, but for genuine power draw when it's being used by somebody to undertake a typical day's work. And we actually use people to do that testing. It's not simulation, because we test across operating systems, form factors, etc., to give a genuine power consumption figure for that device when it's being in use. So our customers range from sort of tech giants, so Microsoft, Google, Acer, ASUS, organizations like that, Qualcomm, are all customers of ours. So they use us for research and testing, but we also work directly with end user organizations, and that's everything from governments to multinationals down to small businesses and charities to baseline using that data, what is your genuine consumption, and as I say, more importantly, what can I do to reduce that? So as an engineer, as you say, with that background in testing, I'm sure you can appreciate the variance when you actually look at what a device uses in a working year, if you like, from those idle and off figures is very dramatic. And that's really what it's about.
Yeah, something that I'm engaged with right now is I'm working with a manufacturer of domestic hot water systems that we're actually installing smart plugs on various of their devices in real situation. It's really fascinating getting a feel for how much these hot water services, and I guess the advent of smart plugs, which do energy management is to some certain extent making it easier. But I remember when you do an energy audit, you'd measure for you basically take a spot measurement or two, because you don't have time to, occasionally you might leave a logger in there for a day, but is that day representative or not? You don't really know.
And I think that's where, IoT and big data come in, because if you can start gathering that information in real time and analyzing it, because there's no point in gathering it and not analyzing it, that's where you can genuinely look at what the implications could be. So, I mean, we recently did testing for a very large international retail organization around running CAD, computer-aided design, on their devices versus running it in instances of AWS's app streaming to see what the energy difference is on the device. Now, obviously, you've got to factor in what the energy consumption is from the cloud provider. But what you're doing is potentially moving workloads from those devices into the cloud, but then that allows you to keep that device operational for much, much longer. I mean, typically those devices, the high-end ones might be replaced every couple of years. Whereas if you move the workload into the cloud and deliver it there, it can be accessed from any device, and that might last you 6 or 8 years as a result.
That opens up the question of Scope 3 emissions, Ewen. So, of course, we have Scope 3 emissions in respect to the manufacture and retailing and of the devices themselves and supply them. Then we've got Scope 3 emissions, for example, if you're outsourcing some of your IT services off your computers to sources like AWS or Microsoft. Is it Azure? I forget which is which now. Then there's Google Cloud. So have you managed to get data from Amazon or Microsoft or Google and be able to quantify those Scope 3 emissions when you're outsourcing some of the load or some of the computing functions to the cloud?
I mean, they're providing that information already to their larger customers, and we're working with all three on projects where they're providing us with data, as I say, to evaluate things like moving those specific workloads and what does that mean. Very much driven by customer demand. So yes, they're starting to open up that information more from a Scope 2 perspective, which is, of course, your Scope 3. The challenge comes when you want to look at the Scope 3 emissions from their perspective as well. That's more challenging. because by definition, their workloads are highly dynamic and can be running anywhere in the world. And so the frequency within which they're replacing equipment in a particular data center, effectively, it's very hard for them to provide that scope 3 data. But again, for the largest customers, they are starting to provide estimations around scope 3. But from a device perspective, as I say, that for us is a critical part of the information that we provide to customers, because if you look at a laptop, it about 80% of its total life cycle carbon emissions are coming from scope 3. So they're coming from the resources manufacturing in particular, and then the packaging, distribution, and then an association with end of life disposal. So if 80% of the emissions for that device are built into its scope 3, then we really need to be encouraging people to keep those devices for longer, rather than replacing them, because the increased energy efficiency of the new device is going to take decades to overcome the inbuilt from scope 3.
That's fascinating, because I fairly regularly, or pretty religiously, replace my laptops every 4 years. And I'm always delighted when I get something so much faster. Maybe I need to be revising that and moving more to the cloud.
Absolutely. And again, going back to the first point, the topic of sustainability has to be played alongside, economics. This isn't just a pure play sustainability story. Keep your device for 10 years and everything will be wonderful. It depends what you're using it for. It depends how mobile you are. It depends what you need to run locally and what you can run in the cloud. And so that's part of the understanding is user profiles, its work styles, its personas. So even if that device is no longer fit for purpose for you, could somebody else in your organization use it as a gateway into cloud services? So one of the other things that we've looked at is repurposing the device by changing the operating system. So by switching that device to a Linux-based operating system, can that device then last much longer than a traditional Windows refresh cycle would allow the device to run? And oddly enough, what we discovered was, and this was through my colleague Justin Sutton Parker's testing, he was the first person to discover this, that in actual fact, shifting to a Linux-based operating system actually reduces your scope 2 emissions as well, because the power draw for a Linux-based operating system is about 19 to 20% less than Microsoft Windows.
Okay, that's fascinating. So because I remember, it would have been 10 or 12 years ago, I was talking to clients and recommending, we were certainly very interested in this thin client solution, which is basically almost what you're talking about. It's where you have a not particularly powerful computer.
Slightly more capable than a thin client because it's mobile.
Yeah. And your statement of 80% of carbon emissions being associated with the scope 3 is kind of pretty staggering. I hadn't heard that before. I guess, just looking at my machine right now, there's a lot of sophisticated technology in it and a lot of advanced manufacturing, which I guess is fairly energy intensive, which I guess would account. But I guess also, if you look at scope 3, you're also looking, are we also including the services associated with network switches and network gear and everything that's associated with using the computer as well?
No, in that case, what we're talking about is a specific life cycle analysis of a typical device. I mean, obviously it varies. So what we do produce, if you are in the public sector or not-for-profit sector, we do have a free online tool you can access. There's links to it from the blog on our website. And that allows you to compare the scope 2 and scope 3 emissions for any device that you might be considering purchasing, to see what its emissions are. And specifically, we tailor that to where you are in the world and how many years you typically keep a device for. So you can literally go on and say, I'm a healthcare provider in Australia. I keep my devices for 4 years, and show me the laptops or notebooks that are available in the marketplace, and allow me to do a side-by-side comparison of those to find out what their total carbon footprint is. And we factor the scope 2 emissions for where you are in the world, and we level playing field all of that so that you can look at a Dell versus a HP versus a Lenovo versus an Acer versus an Asus device of similar specifications, but understand what that carbon footprint is. And as I say, that's available. We call it the dynamic carbon footprint tool. And as I say, it's freely available to anybody in the public sector or charity sector.
And the website is px3.org.uk.
px3.org.uk. Yeah.
Yeah. So, Ewen, what sort of we're looking towards more and more. Okay, I want to step back a bit. One of the things we have in Australia and in the UK, you've got a large amount of wind. In Australia, we have both solar and wind. And this question may be a little bit left field, but in Australia, we have what we call the duck curve. You're also seeing this in California. And the duck curve is due to solar in the daytime, rooftop solar, depressing the overall demand for energy. And then the nighttime, early evening around about now, energy use is its peak. It's 7:20 p.m. where I am. Energy use is right now at the peak for the network. And in the morning, it's probably peak at around about 6 or 7 a.m. as well. Are you looking at all to, in work with your clients, to shifting some of the time insensitive load towards times of day when there's a lot of, I guess, excess energy available, clean energy, to be powering computing loads? And is this just kind of like a bit of a pipe dream? Yeah, we can shift loads around. Because I know in energy efficiency.
It's definitely not a pipe dream. I mean, as I say, one of our customers is Microsoft. And one of the projects that we've been reviewing with them is around that. So specifically things like deploying updates. So Microsoft now have the capability to schedule your updates to Windows 11 based on the carbon intensity of the grid at the time, to use more, to time the energy intensive update process at a time when the grid is expected to have a higher percentage of sustainable energy. So what we can see is, vendors and the larger scale tech providers starting to tap into that data in order to, schedule workloads, schedule changes to maximize sustainability.
Yeah, that's fascinating. Yeah, that's good to see. One of the things, just a bit of a side also, is we're not yet very good at calculating real-time emissions factors. Mostly when we're looking at scope 2 emissions, we're taking the aggregate emissions factor over a year, which is a pretty crude measurement, considering energy use varies quite a lot of time. So it's really interesting for me to see that in some companies like Microsoft are looking, maybe it's not the real time, maybe they're just saying, look, in the middle of the day, we'll just assume that's when there's a lot of...
It's a forward projection. I don't think it's responding to, as you say, a spot energy test on the grid. But it's certainly, as you say, far better than taking an assumed energy position over the year. So I think, as we get into more of that, as I've said before, IoT, big data type scenarios, then we have got the opportunity to start looking at workloads. It's almost follow the sun quite literally. We're going to run this workload, we're going to do this modeling when the sun's shining, or when it's shining in a particular data center somewhere in the world. Well, shift the workload to there. So I think there's lots of that can be done. It's prioritization, as I say. What we shouldn't ignore the potential for marginal gains because they're important. But then we also have to look at things like that massive churn of devices, with everybody doing pretty much, as you said, sticking to a 4-year refresh cycle, because after that, Windows starts to not play terribly well with the hardware, and your user experience starts to go down. You think, well, the best thing to do is get a new device that's all back to default, and then I'll recustomize it. And there's a whole load of lost productivity, but also embodied carbon that's being consumed in that process. Whereas if we can move some of that to cloud provision, and again, we've been doing a lot of work with Microsoft on Windows 365, which is their new cloud-based on-demand Windows. So now you've got the possibility of having your Windows delivered to you as a service to the specification that you need at any given time. So again, if you look at the device, you think, well, I'm going to specify that device for the heaviest workload I would ever put on it. And then that will sit there unused for 99% of the time. But all of those resources have been committed to that device. If you move to a cloud desktop model, you've got a gateway device that can last you for 6-8 years, and then a burst demand on that CPU, GPU, memory coming from the cloud. So you're only using the resources that you need, and you're sharing those resources with multiple others. At the client end, your device is lower energy and longer lasting. So it's breaking that treadmill of constant refresh cycles and manufacturing and in many cases disposal rather than remanufacturing and repurposing.
And I guess that 5G and faster connectivity is kind of opening up the window for this to be more practical, because often people don't want the delay of dealing with, say, a cloud-based service. Whereas as we get faster communication technologies, although I can hear my kids screaming, "My internet's frozen." Yes, but so it's kind of fascinating. We've got this convergence of technologies which are making this more feasible and more practical. I've just got a 5G phone. I don't know. It's going to be interesting to see what opportunities that's going to open up with time.
Yeah, definitely. I mean, as I say, we've dealt in the IT industry with this profusion of silver bullets from, Windows originally back in the 80s through to virtualization, virtual desktops, et cetera, et cetera. They all promised this incredibly flexible, dynamic, cost-effective future, but we never quite got there. And it was typically communication that held us back. What we now see is with that, as you say, 5G communication, with those hyper resilient and performant cloud services, we're starting to get to a point where most of us will trust running mission critical operations in the cloud and connecting to them from a device of choice, which inherently it's more secure, it's more efficient, and if you keep control of it, which is absolutely important, so that means you're running an optimized workload which is suitable for the cloud, and you're watching those costs, then it can be more cost effective as well. I think what many organizations have suffered with is moving workloads and processes into the cloud without optimizing them. So simply lift and shift and put it in the cloud is going to end up with an enormous bill and potentially very little in the way of sustainability benefits. Whereas if it's optimized for the cloud and it's designed to run in the cloud, then you've got those efficiencies at scale. And you see many of the cloud providers as well, with that commitment to genuine sustainable energy rather than renewable energy credits. So we work with some Nordic providers who literally have their data centers right next to hydroelectric facilities, so they're drawing their power purely from the environment, and that is a tremendous proposition in terms of sustainability.
Yeah, that's great. If we're looking at skills in this area, so what do you see as the skills needed? If we're looking at the full life cycle carbon footprint of machines, we're recognizing the benefits of shifting loads to the cloud. So what kind of skills are needed to enable this?
I mean, I think that obviously the IT industry is a very well-established skill set. What it doesn't have is the sustainability element of that. From our perspective, it's really a lot of what we do is trying to intersect between the sustainability teams and the ESG teams, so environmental and social governance teams within an organization who've set their targets and haven't really considered how IT is going to help them deliver that, or how big a part of the problem it is, and an IT team who are technically and managerially qualified, but have never looked at sustainability as one of the things that they've been directed to achieve. So I think it's bridging that gap. So actually having some understanding of, as you said, that full life cycle analysis, optimization, and sustainability in enterprise architecture. I think there's a real lack of understanding of that. I mean, we're seeing now, some people starting to go on sort of, MA, MBA type courses, which look at IT sustainability, and they're certainly increasing. But the majority of the certification and qualifications really are around, methodologies and architectures for IT in isolation. And I think it needs to start to cross that gap to be more joined up with the environmental and environmental management aspects, to say, you're the second largest draw on business electricity after, heating and lighting. So, we do need to start looking at the energy efficiency of IT as being a subject in its own right.
So there's skills for IT practitioners that you think are the critical need: understanding of sustainability, understanding of the impact that IT has on carbon footprints of organisations, and then you're saying they've got the technical know-how to do it.
The role that IT can play in helping the organisation meet its net zero targets. So we very much look at IT being a smaller part of the problem, but also a bigger part of the solution. So if you look at it proportionately, the emissions from commuting, so traveling to and from work, are typically roughly the same as the emissions from the IT industry. So for an organization that hasn't invested in that flexibility to allow people to work from home at least a couple of days, if not 3 days a week, then they're going to have a huge footprint from their commuting. Again, part of scope 3. Their business travel, part of scope 3. So bringing those emissions down through collaboration tools, secure, flexible working is really important. But again, it's often overlooked in terms of what role does IT play in that. So what we really see is that, IT, as I say, can contribute to the organization reducing its overall emissions, not just by running leaner itself, but by contributing to flexible working and similar initiatives.
Yeah, it's an important part of. I've constructed this thing called the energy. This way of thinking about energy efficiency called the energy efficiency hierarchy. At the bottom is a bit like Maslow's hierarchy of needs. You have the essential and you move up. So at the bottom is, can you do without the service completely? And then you move up to reducing the need for the service. And then you look at the system. And this is the kind of the third layer, which is the most interesting layer from my perspective. Is the system design, like, what are you trying to achieve? So if from an air conditioning background, if you're trying to cool people, what's the most effective way to cool people? And then you can start to question the whole design. So it's going back to this: what's the most effective way of conducting business or doing work? And and certainly this is where I guess COVID has been a blessing in disguise, because it's made us much more willing to be able to work virtually. And right now,
that's where
you're the other side of the world, and we're having this fantastic conversation with good quality. Good quality network connection.
We don't need to fly to have this conversation. Absolutely. But I mean, that's where, the third P in PX3 is. So we see them as very tightly interlinked. Yeah. So it's planet, people, and productivity. So for me, IT is all about productivity. That's why we have it. It's to make people more productive in their role. So, it's about how does that tool help you do your job better, but how can that tool have less of an impact on the environment? So again, one of the things that we look at working with manufacturers is around upgradability, repairability. What can happen to that device at end of life as well? Can it be remanufactured? Can the components be reclaimed? And we're seeing that increasingly coming through from customers in terms of their demand at a procurement level to say, well, if you want to supply us with a device, we need to know its total carbon footprint, but we also need to know how easy is it to upgrade, how easy is it to repair, and how easy is it to extract the valuable materials from it at end of life as well, so that it's not ending up in landfill. So somebody commercially can take that device and start to strip out those materials that can be reused so that we don't have to pull new ones from the earth. Um, the amount of e-waste worldwide is absolutely shocking and a big part of the environmental problem. Again, the more customers are aware of the need for energy efficiency, but also that broader total life cycle efficiency, and start to build that into their procurement, the more manufacturers are driven to make their devices from recycled materials, make them upgradable and make them repairable. That starts to flow through into that manufacturing process. So devices that we do need to build have got less of an impact as well.
Yeah, and this is where you're achieving carbon efficiency, and savings. The best time to save energy is when you're designing it, when you're specifying it, it's that essential role of procurement, which I think is just undervalued. The role of well researched, spending a bit of more effort into your procurement effort, and as a result, getting a much better life cycle outcome for the particular product, whatever it is that you're getting. Yeah.
And that's why we launched the dynamic carbon footprint tool, and why we made it free to public sector. So, it's now used by, across UK central government to drive procurement. I mean, it's available to anybody anywhere in the world. It's not limited to the UK, obviously. But really what we wanted to do was also, because you can only be listed on the tool if you publicly state the total carbon footprint of your products, we wanted to address all those manufacturers who weren't producing any information. Yes. They now don't appear in the tool. They won't be purchased by central government. So we saw a sudden uptick in organizations being willing to share the carbon footprint of their devices so they would appear in the tool. So again, that's the sort of thing that we really like to do, to try and raise awareness and drive changes in behavior, both at a manufacturing level, but also at a consumer level, in terms of not necessarily a consumer as in an individual for personal use, but a consumer level as in corporate procurement and public sector procurement.
Ewen, would you mind if I change the topic of the conversation now? I want to talk about you, because clearly you're involved with quite an innovative company. You're a co-founder. It sounds like you're doing some really useful work. And perhaps thinking of younger people now who are kind of just starting out in the sustainability journey, are you able to share with us a bit about your personal journey and the valuable skills, and if you have some advice, say for a younger you, or for someone who's maybe just graduated around, and they want to do something around sustainability. Many of them are quite entrepreneurial. People love the idea of starting up something and making a difference. Are you able to? Sorry, I've kind of maybe put you a bit on the spot here, but you're able to reflect on that a little bit.
Sure. Yeah. I mean, my original degree was in psychology. I then worked for a number of years within the UK gas industry in productivity and management services. And I think that really, those two things coming together, it's about how to influence and drive change backed up by a solid business case. And I think that in-depth understanding of business has really helped me throughout the years. So I did a lot of business case analysis for my organization, and then kind of got the bug for IT, because I saw, working in productivity, as I mentioned before, how IT could drive better productivity. At the time, an awful lot of what we did was manual and paper-based. So the notion of having centralized databases and standardized processes across a very large organization, I think we had about 50,000 people working within the gas industry at the time, really excited me as to what was possible. And so I ended up designing and in fact running the first Windows installation across that organization, and then running that as a shared service internally, and then set up my first IT consultancy business in 1996 and ran that for about 20 years. So I would say to anybody looking at that, the understanding the interplay between technology, people, and business is a key skill, because all of those come into play. And you can't really sell technology if you don't understand the business you're selling the technology into, and you don't understand the people that you're providing that technology to. So I think that's the first point, is none of it is pure tech. It's all an interplay between different factors. And the other thing is having a genuine purpose. What are you setting out to do? Because that purpose will shine through to the people you're dealing with. If you have a genuine belief that you're going to make a difference by doing something, then it doesn't matter how small you are, people will see that and respond to it, because you have a genuine passion for what you're trying to achieve. So I think having that vision of making a difference, and if it's a difference through technology, that's absolutely fine, but have an understanding of what you're trying to achieve, and how this is part of your journey, and project that as part of your business idea. So I think that for me is a key part of being an entrepreneur, is really having that vision of what it is my organization is going to do if it succeeds, and what is it doing as part of its journey. So that's it.
Fantastic. That's really good. Well, Ian, I want to thank you so much for sharing your time today, to share this exciting area of I guess reducing the carbon footprint of computing, and also to share a little bit about your career and your advice for others coming into this area. I really appreciate it. Thanks, Jon.
No problem. Very nice to speak to you, Bruce.
Thank you. Thanks.